We have a graph of the accumulated rainfall in Las Vegas, Nevada in the first 60 days of 2017. Use the graph to support your answers to the following questions. Is the accumulated amount of rainfall a function of time? And is time a function of the accumulated rainfall? So really dig in deep and remember what we talked about when we talked about functions and function notation. We learned that this year, last semester, but this school year. So, and I also mentioned to you when we did go over that stuff, that it's something that shows up again and again and again. Actually, a lot of things show up again and again and again. And you'll see like in this unit, it'll just now be more related to exponential function. So really, in my opinion, nothing much new today, but it was a struggle for Sauer. It really was. So please like dig in deep and try to like jog your memory, maybe take better notes since a lot of people are forgetting. But let's answer number 1 first. So is the accumulated amount of rainfall a function of time? So function of, or in other words, f of x, that's literally read function of x. Okay, if you don't remember that, the way you read this is function of x. When you read a problem that says blank is a function of blank, in case you struggle with figuring out what should be your x and what should be your y, what follows the phrase function of should always be your x. So this is saying that my rainfall, y, is a function of time, x. Look at my graph. The time is on the x, the rainfall is on the y. Is this graph a function?
Yeah.
And what makes something a function as well? Like, how do I know it's a function?
Every Y has to have something. With every input has to have something.
So every input has exactly one output. Every x has just one y. Okay, so then if we're looking at this, it looks like it's going from 0 to 60. There's not going to be an input there. There's not going to be a day where we had 2 different amounts of total rainfall. Okay. Also, if you remember that vertical line test, at no point does it fail. Like at no point does the graph touch a vertical line more than once. Okay. So just refresh that memory. If the x's don't repeat, it's automatically a function. So if I say rainfall is a function of time, that is correct. Now, is the reverse correct? So is time a function of accumulated rainfall? That just depends. So basically, if I were to put my paper in this direction and think of it as rainfall in this, where the x normally goes, compared to the days. So like, say we started day 1, 2, 3, 4. What does it look like the rainfall is from days 0 through 4? It looks like 0 for all of them, right? Anyone disagree with me on that? It looks like, and it probably even longer, like probably even past the 10. It looks like the amount of rainfall was 0. We know that for it to be a function, none of the x's should have different y's. But when we look at it as rainfall compared to days, where rainfall is now the x's, I have a bunch of x's that repeat with different y's. So for this one, you would say no. Time is not a function of the accumulated rainfall. When we do it like the normal way, like when we do days compared to the rainfall, then there's no repeat. But, the reverse is not true. So I guess the answer is like, it just depends. But most of the time when we're writing these out, it should always go in the order function of X. This one down here is going function of what my Y was. That's not true for this situation. So questions on that? No. Really, the whole key thing there is jogging your memory about functions and function notation. So let me read you the learning targets today, because that's how you know you're successful or not. We are going to be still exploring exponential functions and finding meaningful ways to represent them using function notation. Okay? Function notation, you should automatically think of what? So hold on, let me give you a few examples. Maybe that would bother you. So say I have, because this has shown up on a test before, 3 different equations, and there could be numbers in it, I just chose all variables. 3 different equations, and the question on the test will say, which one is in function notation? Raise your hand if you think it's the first one that's in function notation. Raise your hand if you think it's the second one. Raise your hand if you think it's the third one. Okay, the third one's in function notation. So what is function notation? What part of it makes it function notation? The f of x part. So bringing it back to f of x, which equals y, where x is your input, y is your output, and f would just be like the function name, like function f, function g, whatever you want to call it, but it's just notation. So when we're talking about writing equations to represent exponential functions, if it wants it in function notation, just instead of y, put f of x. That's really it. We're going to practice that when it's a table equation or a graph, and analyze the situation for what it represents, all of which we've done before, but now it's specific to exponential functions. I'm recording right now. Last year, these 2 lessons were split. They really don't need to be split. It's basically the same thing, and also things we've done before. But I didn't want to go and make it harder on myself and combine your puzzle pieces. So it's still 2 separate puzzle pieces, but it's not very many problems. Okay. When you go and prioritize what you need to do to understand, they're there for additional practice. No more assessments this week. Was that one quiz from yesterday, but we're done with that. Speaking of that quiz, I do still kind of need to just go back and check the answers that were submitted, because some people could have gotten partial credit. Just they maybe rounded wrong or put an extra decimal point, and it's just, I need to go back and check it. So that's why I don't want to sync the grades for it yet without having done that first. It is viewable and you can go and do corrections on it even now. So consider doing that. And trust me guys, like I know your parents are probably hounding you about anything that's like missing or anything that still needs to be updated. Like I update grades multiple times a week, but the policy is within 7 days that you turned it in. So once you turn it in, please wait 7 days, and then if it's still not updated, feel free to message me. If you just turned it in, I don't need that like reminder. I will get to it when I have time. Very busy. Yes. Yes. But please, like, if it's been more than 7 days since you turned it in, reach out. But I'm very good about that. I don't usually make mistakes in that regard. Like I'm just busy, gotta make all the lessons for this week and then go back and update grades. Yes, thank you. Let me get back. So now back to the activities. So Claire noticed mold on the last slice of bread in a plastic bag. The area covered by the mold was about 1 square millimeter. She left the bread alone to see how the mold would grow. The next day, the area covered by the mold had doubled, and it doubled again the day after that. If the doubling pattern continues, how many square millimeters will the mold cover 4 days after she noticed the mold? And show your reason. I'll give you no more than I'd say 1 minute, maybe 2. We're just gonna do number 1 before we move on to the rest of them. This is like what we've seen before. So give it a shot, talk to your group, make sure you come to a consensus. We'll assign reporters so that everyone's held accountable. Based on that situation, what should the answer be? What's the answer? What? How many square millimeters will the mold cover 4 days after she noticed it? All right, table 6 has the floor, where you'll get your chance. $16 square millimeters. And what did you do to get that answer? After, I just like, added 2. Oh, about 4 days. You added 2 each time? Yeah. Okay. Did you make a table, equation, or a graph? Okay. Well, I don't think adding 2 each time would do it. But what should it be that you're doing each time, Jack? Timesing by 2 is what you should be doing. And if that's what you truly did, then the table is probably like how you could organize that information. So XY table, or they did give you specific variables to use. They wanted D for days, or I guess they didn't really say, but, oh yeah, that's right here. D for days and capital A for area. Or you can make an XY table and just know which is which. Time is almost always the X anyway. And it's from day 0 would be like your start, don't forget that, through up to 4 days. And at day 0, how much square millimeters of mold was there, class? 1. And then it's doubling each day. So double of 1 is, double of 2 is, double of 4 is, and double of 8 is. So it is 16, but don't assume that it's adding 2, it's timesing 2. So good so far on that? However you get the right answer, 16, at the end of the day, it really doesn't matter which one you do. But say you want it at the end of 100 days. Would you want to necessarily keep that going for 100 times? So then, that's why we're still gonna practice these other 2, even if that's not what you did in this one. So table 7 for the equation, can you just tell me what like the basic setup is for exponential functions?
I think, 1 parentheses 2 to the power of days.
Okay, good. And we can make it equal to capital A, our area. It did specify what variable it wants you to use, but you've seen us do Y here and X there. Okay, or T third time. But the basic, since it is an exponential function, is the Y equals A times B to the X. A stands for what? Table 8? Starting amount, which 1 is my starting amount in this one. And the B stands for what? Table 9. Use but B. The like days, or not the days, what it's multiplying by. What it's multiplying by each time. We otherwise call that our common factor, but that is what we multiply by each time. And I kind of meant to ask you guys this earlier, but since it's doubling each day, we know that's exponential, so we know it's this format. And so really all we have to identify is our A, B, and for whatever time frame they want. So what time frame were they looking for? After 4 days. So then when you put 4 for the exponent, you do get 16 as a final answer too. Now, based on our information, I'm gonna have you sketch a graph. All right, I think the only thing I'll help you is this part. From there, sketch a graph based on our information, because that'll meet one of our targets here in a second. I'll freeze it so that you don't just copy that. So now that you compared your graphs to each other's, take a look at mine. Like earlier, I wanted to, I guess, make it bigger. I don't really need to, I guess. It went up to 4, so I don't need to make it bigger. But if you did, we know what the pattern is. We have the equation, like we could add more data values and extend our graph, but I just left it as is. So if my days went from 0 to 4, they're there. 0 being like your origin. And if my data went from 1 to 16, then I just counted by 5s on my x-axis. Now, a question that would meet one of our learning targets is whether or not I can and should connect those dots. So don't just say it out loud, just kind of think through it. Like, should I connect them? Should I leave them as separate dots? So when you're thinking about that answer, so again, don't just shout it out, just think about it. Think about, can there be fraction of a day? Can there be a fraction of a square millimeter? Is the mold like going away and then coming back, or is it there the whole time? So thinking about all of that stuff, talk in your groups. Should we connect the dots or should we leave them separate? So it's either we connect them or leave them as is. So should the dots be separate? Raise your hand. Should the dots be connected? Raise your hand. Okay, so those of you that raise your hands are correct. You should connect them. Because you can have a fraction of a day. You can have a fraction of a square millimeter. And the mold is there the entire time. It's not like it's going away and coming back. So you should have them connected. This would be a continuous graph. Yes? All right, so that should meet one of our learning targets, like determining whether or not it should be a continuous graph or a discrete graph. Last part of this one, and I think I'll cut and paste it so it's on the same page, but it's your number 3. Should it be that area is a function of time? Should it be that time is a function of area? Is it a function at all? So answer number 3 on your paper, and then we'll move on. Yes. Okay, so looking at our graph, or you could even look at it in a graphing calculator, just type in 1 times 2 to the x power, and it'll have a line graph for you. Is this a function? Do any of the x's repeat with different outputs? So then it is a function if you look at it this way. So in that case, would it be that area is a function of time or that time is a function of the area? Table 9, what would it be?
Having areas of function.
All right, so let's see if that's true. One thing that helps me is remembering function notation is read f of x, function of x. So function of what follows that is time. Is time on the x-axis? So that sounds pretty good to me. And it is a function when we look at it. If I were to do the vertical line test, it doesn't touch more than once for the same day. It might look like it because it gets really steep at some point, but it's still like for each day, there's just one answer. Questions on that? Okay. So to practice function of what, there's that little part on your paper that says functionally speaking. There's two situations, both of which we've seen before. You're going to fill in the blanks basically, except for there might not be blanks on your paper, or there might be, I don't remember. But for each one, look at the two things being compared, be able to tell me, this is a function of this. And then make the equation for that situation. I have faith in you, I'll give you 3 minutes. Fine. In number one, what are the two things being compared? Who was the reporter? Who was the same reporter before? And the question is, what is being compared in number one? That's not what I asked you. I said, what are the two things being compared?
Oh,
Bacteria and time. Specifically in hours, but those are the two things being compared. So I know I'm not like your English teacher, but you have to be able to read and understand what's going on. That's a very like minimal skill. What two things are being compared? Bacteria and the number of hours. So then table 2, between the two things being compared, and what usually helps me is imagining like if I had to graph them, what should be the X, bacteria or hours? Hours would go on the X. Bacteria would go on the Y. Time is almost always on the X, so that usually helps. So then when we're saying blank is a function of blank, remember that function notation. I tried in that unit reminding you guys that whatever follows the word function of should be the X in that situation, to be on the X-axis. So then table 3, what is a function of what? So bacteria is a function of hours. Or however you want to phrase that. The amount of bacteria depends on how many hours went by. Not the other way around, right? And I guess you could like probably reverse it a different way and still see if it's a function, but really it should go this way. For each hour, there should just be one answer for the number of bacteria. Questions on that? Now, table 4, because I also asked for the equation, even though your paper might not have. So table 4, what would be the equation that represents this situation? So reread the situation based on the wording. Should this follow a linear pattern, an exponential pattern? Those are really the only two we've talked about. Exponential. So we know that our basic exponential functions are this. if I wanna make this function notation, by the way, because it does say using function notation. How can I make this function notation, class? F of X for the. Okay. So now it's in function notation, but we need to put it with the values that would normally get replaced with numbers. So table 4, we're gonna leave it as F of X, but then it should equal what? $50 for my starting amount, good. What would I have to multiply by each time if it's splitting? 1/2, good. And then to the X power, they didn't specify what hour they want us to solve for. When they do, I would put that in for the X. They also didn't specify what variables to use, so I just did this. X and Y for input output, except for now, if I want it function notation, I do F of X. Good? Okay, table 5, hopefully it's getting faster. I mean, I feel like I have to pull it out of you, and it's, hard. Things we covered. Table 5. In number 2, what are the two things being compared? Area and time measured in days, good. So then table 6, what should go on my x-axis? Good. So that tells you days should be x. This helps me remember what should be x. Time is almost always on the x, days is the x, that means the area is the y. In this one, it does want you to use t for where we normally put an x. It doesn't really say anything else. If t is for my days, which is normally x, then I'm gonna put it in the parentheses for my function notation. Now, table 7, you're gonna finish this. You're gonna make the equation based on this situation. So I'm gonna Kaylee set up. We are making the equation now. Guys, it's like we've even done this exact situation before. Like, I don't get it. Read it. Read what's going on. Would that follow a linear pattern or an exponential pattern? Table 7, tell me that. Okay, so it's adding the same amount each day? Or subtracting the same amount each day? I haven't even gotten to the back side. Like, this is just driving me crazy. It's things we do every day, every single day. If I am reading this and it says that 1/3 of the previous day's area remains, would that follow a linear or an exponential pattern? Is that an answer to my question, John? The question I'm asking, not what the equation should be. Okay, so here's the problem. When you guys don't answer my question for like what the answer should be, I have to now make those questions easier to walk you into how to get this answer. Even though I think it should be easy, that you should just tell me what the equation should be. We're now past that. I've gotten a bunch of I don't knows. Now we gotta make it less hard, I guess. So how about Harley, instead of looking at your phone, you read this out for the class? Because you're part of that table, I've been asking that table this question for at least 5 minutes now. So go ahead, read this out loud for the class. Okay, thank you. So then table 7, continuing with you. We gotta get you to answer at least some part of this, right? If it's losing, or it's actually keeping a third of it each day. On day 1, what did it have, table 7? Table 8, remember, it's keeping a third of its volume. So how much would it have after 1 day if it's keeping a third of 240? $80. Table 9, after another day, if it's keeping a third of its volume, how much is it after 2 days?
26.7.
26.7. This is not following a linear pattern. Those are my tables that did the math. What were you typing in your calculator each time?
Divided by 1/3.
Or you mean times 1/3? You could do divided by 3 or times by 1/3. It's the same difference. I'm telling you that. It's not a linear pattern because it's not subtracting the same amount each time. It's either, in your eyes, multiplying or dividing the same amount each time. So that's an exponential pattern. So it needs to follow the a times b to the x. But sometimes they change the variables out, like right now, x is gonna be t and all that stuff. But a and b are always representing the same stuff. So then table 1, so rotate the reporter, whoever spoke for your group last, so like 1 to the left. Table 1, what should my a be? If it's exponential, we know it follows this format. What number should I put in for the a? 240. Because that's my starting amount. My b, table 2, should be what? So Scarlett spoke last, so I'm reading 1 to the left would be Adriana. What's gonna be my b? What am I multiplying by each time to get to the next number? Maybe reread the problem. It does mention this. There's a reason we knew how to get to these answers. A third, yes, love it. A third is what we're multiplying by. And especially because some people will confuse and put 3 there, because they're dividing 3 each time. B is what you have to multiply by each time. So multiplying by a third is what we were doing each time to get the next answer. Let me change that x to a t, because this time my input is t, they specifically wanted you to use. It's in function notation because of this first part that's in blue. But the rest is stuff we've done before. We've even done this exact one before on a different note sheet. Questions? Okay. I need to go fast on this last part, so we're just gonna jump ahead, but like, stay alive, stay with me. This last part, I hope, is easy. It's function notation. And now just relating it to our exponential function. So in this one, the cost in dollars to produce 1 watt of solar energy is a function of the number of years since 1977 or T. You have a bunch of stuff in function notation. You are going to answer these using the graph. Okay, so Remind yourself how to do that, maybe talk about that in your groups. Maybe I'll even help you out a little bit because we're low on time. This right here is in function notation. F of 9 is approximately 6. The 9 is replacing what usually for function notation? The x, because function notation is f of x equals y. Right now they have it as f of 9 is approximately 6. So the 9 is replacing where the x would normally go. What does it say on my x-axis? So this would be 9. Say it. 9 what? 9 years since 1977. You could say that, that's a little long to say. So how many years? So 1977 plus 9 is what year? (1977 plus 9 is what year? 1986. So you could say 9 years after 1977 or shorter, it'd probably be to say in 1986, it costs approximately $6 per watt. How did I know that? I reread the first sentence that it gave me. The cost in dollars to produce 1 watt of solar energy is what my y-axis is. The 6 is replacing where my y would normally go in the function. So that's what you're doing. In some of them, you have to tell me what the answer is. So like, what does f of 4 equal? What does f of 3.5 equal? Use your graph to do that. And then be able to tell me what it means. For what? Whatever it equals, what does that represent? You're doing that for each. Questions? Okay. Hopefully I presented it better than I presented it first hour because it was a struggle. Refer back to this example when we go back over these, I'd say, in about 5 minutes. What is the value for f of 4? Based on this graph. Sorry, one more time. That is correct. Thank you. You remember how to find that from the graph. What is it for replacing, an input or an output? And it's in parentheses. So that means you should be looking on your x-axis, where it's 4, seeing where it touches on the graph. When I go up, that value on the y is 25. That's how we know that. Done that before, I promise. Now, what does it mean? Table 4, can you tell me what it means in this situation? For what? 25 what?
4 years.
No. 4 years.
$2.
Okay, 4 years, it says years since 1977, so you could say 4 years since 1977. And then what about the 25?
It's $1 per watt.
It costs $25 per watt. Whatever X represents, now attach the 4 to it, so 4 years since 1977. Whatever the Y represents, attach the 25 to it, it costs $25 per watt. That's all. That is all, I promise. We've done it before. Table 5, what's the answer for what f of 3.5 is? Okay, let me double check. So 3 is here, 3.5 is here. I agree, that's about 30. Now, what does it mean in context of the situation? Table 6, can you tell me? Maybe try reading the axes again, but be able to understand when it's in function notation. How do I attach it to the real world situation? Table 6. 3.5 what? So is it 3.5 replacing the y? It's replacing an x, so try again, 3.5. So 3.5 years since 1977. It costs how much? $36? $30 per watt. Good. Table 7. When it says f of t equals 45, what does the t have to be? Okay, we didn't get this far earlier, so I have to double check. 45 would be here. Did you say 2? 7? I thought I heard a longer number, but it should be 2. Because here's where 45 is on the y. It gave us a y this time. See where that touches on the x, it touches at 2. What is the t equals 2 mean, class?
Yeah, 1997.
Okay, good. Can you tell me what year that would be?
1999. 1999.
Okay, good. But we can keep it how we've done it before. The factor that it's changing by each year. Okay, everyone relax. Everyone relax. We're on the last problem. Can you relax? Just listen. Even if you put your notes away, like already, just everyone stop moving. The factor that the cost is changing by. So what are my y's changing by? And it says if you get stuck, consider making a table. So at my initial start, it was how much? And then after 1 year, it was, after 2 years, it was 45. Even this should probably be enough. How can you easily find your b, your factor? Do you know what you're multiplying by each time? Divide by what? Okay, so an easy way to find it would be to take one of the numbers and divide it by its previous number. That should also give me the same amount if I did this one and divided by the previous one. Then that'll give you the right factor. Just side note. So I got 0.75 for it to be right here. Oh, see you. Oh,